So anyway, this could be a very bad sign if I'm remembering things. Anyway, let me get started by now all I have to do is figure out, wait, share screen. Yeah, that's what we want. Yeah, that's what we want. Desktop one. Okay. And now we get rid of that. And here we go. And get this stupid thing out of the way. And I think I'll probably have to. Oh, great. Now something else is. I'll have to raise this. And okay, now we fit. Now we fit. Here we go. Twiddle and make it a smidge better. Okay, let's proceed. I mean, guess what I'm going to be talking about today? Over the last 2 weeks, I've spent a lot of time. No, I haven't spent a lot of time. I have spent time trying to do research on storylet technology. However, the amount of information available on this is very limited. I'll give you an idea by showing you the results of various Google searches. If you look here, a Google search for storylet yields 1.6 million results. One for rutabagas yields 12 million results, and aardvarks get 9.6 million results. So storylets are vastly less well understood than either rutabagas or aardvarks, or at least talked about. So if you really want to be popular, talk about rutabagas, not storylets.
Actually,
Yeah.
if you want to be popular, you should talk about things that are less talked about, because then you can get a niche, then you can get more of an audience.
Well, yeah, big fish in a little pond kind of thing. I don't know. But if you're starting a political party, you're much better off choosing rutabagas as your symbol than storylets. So actually, Emily Short's stuff is far and away the most commonly cited stuff, and she has basically 2 essays and a lecture. And there was an article from 2015 and a bunch of other I went to a variety of discussion groups thinking, well, this is a fast moving technology. It's, the news and ideas on it are being developed in discussion groups. So I went to the Discord group for the Narrowscope convention thinking, well, I'll probably see some stuff there. And here's what I got. In the Narrowscope topics, there isn't there isn't a single topic about storylets. And when I searched for storylets for the entire area of Narrowscope, I got 7 results, 7 comments, 2 of which were mine. So there's not a great deal of information available on storylets. And this is disappointing because one would think that if this were a well-developed technology, then you'd be able to go into a college bookstore and find a thick book, entitled Mathematical Principles of Storylet Architecture by Professor Thaddeus von Dork. But no such book exists. And so we are kind of left out here. There's just not a lot to work with. So, but I'd like to make a point, though, that storylets really are not a new technology. They're not even remotely new. They are based on concepts that were developed way back in the early stages of computer technology. And very early. If we go back to the late 50s and early 60s, when IBM in the first generation, really, I suppose you have to call it the second generation of IBM commercial computer products. By the way, Can anybody recognize what the woman is doing? Yeah.
That's a card reader.
Very good.
Oh,
Very
yeah.
good. Yes. Anyway, so back then, I mean, things were really expensive. A machine like this would rent for the equivalent in modern dollars of $20,000 per month. Okay. And boy, they just didn't have a whole bunch of, by the way, here's some of her punch cards right there. This did everything was pretty primitive. For example, here is, whoops, let's go back. Thank you. Here is a core memory card. You thought core memory was, oh, wait a minute though. Let me show you something here. Here it is. My very own core memory card. 16 kilobytes of random access memory. Wow. Get a close-up look at that. Ooh, yeah. Let me show you the stuff. Where are we? There we go. So anyway, this is what the core memory card looks like. And can we move you down? There. So this is what it looks like. It's called core memory, not because it sits at the core of the computer. By the way, this card cost the modern equivalent of $13,000. When I was in high school, I worked at cleaning up at a factory where they manufactured these things. They had all these women with dissection microscopes and little bowls full of cores and needles with wires on, and they would thread them. Oh, God. Anyway, here's a closer look at the things, and here's an even closer look where you really can't see, but each individual tiny thing in there is a core. And here's close up. A core is a donut of ferromagnetic material which can hold a magnetic field. And by passing two wires through it, you could either sense or write. You could write to or read from it. And these things were horribly expensive. So you didn't have a lot of core memory in your computers back then. And hard disk drives were insanely expensive. They hadn't developed the technology. Basically, these things were pretty close to custom manufactured. I mean, the heads on them, it was just completely, all aspects of this technology were radically new. Now, the primary mass storage device was the tape drive. These things were cheap, relatively speaking, but the big advantage was one tape reel could hold an enormous amount of data. It was the only way to store large amounts of data, but there was a problem. Your computer cost $20,000 per month, and the tape drives delivered data at about 7 kilohertz, 7,000 bytes per second. But your CPU was racing along at a blistering speed of 87 kilohertz, which we might laugh at now, but that was still more than 10 times faster than what the tape drives could deliver. And so if you just hook the tape drive directly up to the mainframe, then the mainframe would spend 90% of its time waiting for the tape drive to deliver another byte. And at $20,000 a month, which is roughly about a penny a second, you can't afford that. So they needed a solution, and the solution was to use a small amount of core memory in the tape drive, built into the tape drive, that acted as a buffer. So the tape drive would load data into the buffer, and once the buffer was full, the buffer would send us an interrupt signal to the mainframe, and then the mainframe would go back and interrogate it and get the data. And if you think about it, this is the ancestor of storylet technology, because I forgot to give the definition. This is one of the few, Emily Short's definition of storylets is one of the few things that seems to be universally agreed to, and that is, let's see, a storylet consists of first, some narrative content, text, video, images, music, whatever. Second, and this is the crucial part, a Boolean expression that specifies whether the storylet is to be selected given current circumstances. And third, some algorithms that execute when the storylet is executed. So those are the three elements. And in fact, that second element is the crucial one, and that first showed up right here, because that core memory, in effect, had a little algorithm specifying when it was full, and that's when the mainframe interrogated it to get the data. So that was the very beginning. It wasn't really the full thing, but it was the first step. I'm going to jump way ahead now. There's an awful lot of other stuff in between, but I'm going to take a huge leap to 1986, and this game by Doug Sharp, The King of Chicago. This was the first game to have storylets. He had a system where there were fragments of story that would pop up under appropriate circumstances. And unfortunately, there weren't enough storylets. And so King of Chicago was handicapped by that limitation. A year later came my design, Trust and Betrayal, and this had the concept of storylets taken even further, or at least some of the relevant concepts. It had an inverse parser. Now, to explain an inverse parser, first, I got to go over what a parser is. But let me ask, does everybody here know what a parser is? Okay,
Yeah.
then I don't have to explain it. Here's standard command line interface with parser. The green stuff, the stuff preceded by green, are the actual commands being given. And as you can see, this is real crap. This is
This is my day-to-day work.
Anyway, this was the way it was done, because parsers were much easier on the computer. Basically, in terms of workload, parsers cut down the workload to the computer by greatly increasing the workload on the human. The human is doing all the computing, and the computer doesn't have to do much, which I suppose is fine when you're paying $20,000 a month for a computer running at 87 kilohertz. But by the 1980s, these things were definitely going obsolete. And with passage, they're now totally obsolete, and yet they're still being used for things like Linux. Anyway, what I had with cboot was an inverse parser. Here's an example. The idea is, rather than having a parser go through a complete sentence and figure out what all the words mean, the words are presented sequentially to the player. So here's a sentence that's almost finished, and the very last word of it here is presented in a menu to the player. So rather than having to memorize the structure of goal, or account, Zuby, Sordicott, Blue Oregon, it just gives you your options as a menu. And this is a much cleaner, easier interface system. Unfortunately, I did not invent this. It turns out, I discovered much later, Texas Instruments had patented this basic concept in 1978. So only they had no idea what to do with it, and I don't think they used it for anything. But anyway, I was the first person to use inverse parser on personal computers, as far as I know. So anyway, here's the vocabulary that I had for for my language. You can see there weren't that many words in it. By the way, this is color coded just for educational purposes. The real elements were just plain black and white, and you could form complex sentences with it. Here's one of the most complex sentence you could write, which was that this character makes a deal with this character here, under which this character will tell the other one how many of these things somebody has, and this character will tell the other one how many of these things the character has. And so that's a deal. Actually, that is not complete. That you have to specify whose they belong to, but that's another issue. So here's what the game screen actually looked like. So here was this guy telling the moose here that nobody has betrayed this character. And Moose in return tells him, this is sneaky telling, whispers to him, betrays that this character has of this stuff this many. So anyway, that was the inverse parser in Cebu. I will show you. You recall how every one of these has a Boolean expression that determines what will be selected. Well, for Cebu, there was a Boolean expression to determine which word would be selected. This is, in fact, oh, I'm not showing the whole thing. This is, in fact, the Boolean expression used in Cebu. That is one expression. Oh, and it's preceded by 3 pages of code defining all of these intermediate variables like histo-k and wtel and so forth. So this is real Boolean selection for you. So let me see if I can make this. There we go. Now it fits. Anyway, I also in Cebu, this was the first expression of the encounter technology that I've rebuilt recently, but I had it in Cebu. It was simpler, as you can see. I'll point out 2 interesting oddities in it. First, it had text variables to fill in, who you're talking to. The conversation with this character's name has been going on for some time when personal pronoun turns away from you for a moment and you suddenly realize that personal possessive pronoun, blah, blah, blah. And then the other cute thing is right here. This is this is an algorithm. It carries out a calculation using an RPM calculator that I programmed in. RPM, reverse Polish notation. You all know what that is, right? How about reverse Clausewitz notation? If you've used the Hewlett-Packard calculators, you know what this stuff is, but it's a really powerful system. Much better than those stupid all the other calculators, the way this system can build, you can do almost any calculation with this, whereas with the conventional calculators, it's really difficult to do a complex, if you got a lot of nested parentheses, this slices right through them. Anyway, I built one of these little calculators in software, and this is one of those calculations. So Anyway, so that's by 1987, we had seen the first implementations of this kind of thing. Now let's move into interactive fiction, which actually started much earlier with text adventures, including the come on, Great Colossal Cave. What was it called? Colossal Cave?
I think it was Colossal Cave Adventures, I think. That's ringing a bell.
Yeah, that was the first text adventure. And text adventures were basically just complicated text puzzles. And there were some very clever ones, and there were also a lot of really disgusting ones. They were just way too complicated. Here's an example of a conventional text adventure. The yellow here is the person's command. And and then it dumps a lot of text on you in response. But then people started using text adventures to do more highfalutin stuff, and they preferred the term interactive fiction. And so here's sort of what they morphed into. You know, we make some pretty pictures, some nice layout, and so forth, and it has evolved from there. The problem, though, with interactive fiction, or its greatest strength and its greatest weakness, arises from the fact that it has a very tight community. You know, there are interactive fictioneers who together, you know, they breed together and drink together and so forth. And I mean, they know each other. They have, for example, this Narrowscope conference coming up in June, I think, is a conclave of interactive fictioneers. And of course, it has also expanded somewhat in, you know, choose your own adventure stuff and so forth. And actually, one of the greatest strengths of interactive fiction is that it has a huge selection of development tools, some very advanced ones that have been around for years in Form 7. Come on, begins with a T, Twine. And there's a third one. Chris, can you tell me what the third
Probably choice script.
Yes. So, but there are a lot more. And it seems like one of the things that people like to do is build their own little text adventure, interactive fiction development environment. And there are lots of highly specialized ones. Hey, you want to do one about with only women in it, or, you know, one about gay relationship. You know, they can do all sorts of different things. Anyway, so you've got this community, and all these people are working together, but they're really tightly characterized. They are, I suppose you would say, they are amateurs. I do not mean that. I mean that in both senses. There's the pejorative sense of amateur, of unprofessional, doesn't really know what they're doing. But another important, actually, the original meaning of the term is somebody who does it for love, as in the Latin verb amo, amas, amai. So the interactive fiction people really are in love with this medium, and they work on it. They don't get much money at all. Chris, would you estimate how many people actually make a living working in interactive fiction?
Out of like the players, most of the players are also authors, but people who like work professionally, that I'd say maybe 10 or 20%, and the people who make a living is much smaller than that.
Yeah, so you don't go into this to get rich. People do this for love. And it is also true that that these people are not technically high powered. They're not geeks. They're not dorks. You know, they have real difficulty doing hairy programming, except of course for this upper crust, the elite. But the great majority of these people are very lightweight when it comes to programming. And that's one reason why some of these development environments use scaled down programming languages, or perhaps I should say programming languages with guardrails rather along the sides of the roads rather than cliffs, as in most programming languages. But this is also one of the weaknesses, and it shows up here. Most of these people, most of the code I have seen is highly Boolean in nature, and there's very little arithmetic being used. There's not much numeric calculation going on. The development environments do permit it. They have all the standard calculation capabilities. It's just that it's not used very much. Chris, do you want to comment on that? Do you think I'm being a little too harsh here?
Well, I don't know. I mean, it's varies. I'd say a lot of the development environments don't even offer a lot of math possibilities. Some do, but a lot of times it's more constrained.
Okay. Okay, so this is a major problem, in my opinion, because Boolean logic is so much more limited. Think in terms of word size here. Boolean is 1 bit. It represents the universe in black and white. Arithmetic, it allows grayscale. So you can represent reality a lot better with numeric variables than Boolean ones. A Boolean version of romance divides romance into either white or black. Very simple concept of a romance. And I think you'll agree this is totally insufficient. So for all of these reasons, I reject interactive fiction as a likely source for really developing interactive storytelling. But they have gotten excited about storylets, and we are seeing some interesting efforts in that direction. Look, Chris, I could not figure out just how popular storylet concepts are in the interactive fiction community. Do you have a feel for that?
Not really. I mean, Emily's the one who talks about it the most. Yeah, I mean, I think like Sasha's tool is probably like the most developed thing editor that I've seen specifically for writing storylets. Like I know that what's the name of the company that made the Sunless Sea and Fallen London? They had a tool, but that went defunct like 8 years ago.
Feel Better Games is the name of that company.
Yep. Yeah. They launched a tool and it like died within a year.
Wow. Well, I've forgotten what I was going to say. So here's another.
Wait, sorry. Chris Conlon, when you say it died within a year, what do you mean? Like, how was it not released? It's unsupported. You can't use it?
Yeah, like as of 2 or 3 years ago, they stopped even supporting and hosting the games that people had made on their website. But like after a year after it launched, they like had very little uptake, and I'm not even sure that they allowed people to start new projects. They just let people update their old projects. And then as of like 3 years ago, they stopped allowing even that.
Okay, thank you.
I was under the impression that maybe it was in Form 7, had added some features that supported storylet technology. Is that correct?
I don't know. I haven't followed the development. Like 2 or 3 years ago, it finally went open source and people have made additions to it, but I haven't followed any of them.
There was a lecture at Narrowscope either last year or the year before about storylet technology, and someone added some features to Twine that help support storylet based stories. That might be what you're thinking of.
Yeah, I think that's it.
Could you link that? That sounds interesting.
Yeah.
Okay, now actually, now that I think about it, this whole section that I developed is probably a waste of time. So I will push through it. Another approach to interactive storytelling is directed graphs. Basic concept: you take a standard tree and woo, you can loop back. Wow, what a concept. And I think I've shown you guys this before with a big directed graph that turns out to be Pac-Man. So, gee, Pac-Man is a directed graph. How impressive. And there's Storytron, which was a little bit overcomplicated. And here's the best part here. And this is what happened to Storytron. Oh, well, never mind. So that approach not solve the problem. But now I'm going to raise the real killer problem, which nobody has talked about. And it goes like this. Here's our graph of a story. I've got to shrink this here. There. Come on. Come on, guys. Shrink. Shrink. Why would
Maybe the zoom at the top left corner.
yeah, that's it. Okay, there. Thank you. Okay, so here's basic architecture of a story. Here's the architecture for interactivity, where you get to make choices. So you put the two together and you get the standard tree, la-di-la-di-la. But there is a problem with the tree, and that arises from the fact we normally think that, well, the tree has exponential growth, and so after n turns, you're going to have 2 to the n leaves in the tree. But I'm going to approach this problem in a completely different way. Let's talk about stories and the way elements in a story interact with each other. My key point here is that in a well-designed story, almost every element somehow refers or connects with some other element of the story. For example, in the very first Star Wars, Obi-Wan Kenobi tells Luke that Darth Vader betrayed and murdered Luke's father. But then in the next movie, it's a whole movie later. But that's really a huge connection between 2 events. And then later on, we come to this. So, and in fact, Darth Vader saves his son by murdering the Emperor. And so that's in the 3rd movie. So these connections can really span a huge range of storytelling. And that can be a problem, because if you have a system of just 3 nodes that are interconnected, there are only 3 connections that you have to worry about. But if you have 4 nodes, there are 6 connections. 5 nodes means 10. 6 nodes takes you up to 16, and 100 nodes, that is a story with 100 events in it, will have nearly 5,000 connections that must be attended to. In other words, if you design a story world with just 100 events in it, you've got to consider each and every one of those 5,000 connections. You can't do that. That's impossible. That's why it's so difficult. Let me expand on this. Here's also Star Wars 1. Here's an event.
Oh, he can't stay here forever. Most of his friends have gone. It means so much to me. I'll make it up for this. I'm sorry.
So, okay, there are some events that don't have any bearing on the rest of the story. Let's just cut it in half then. That still means there are 2,400 and 2,500 connections you have to worry about in a 100 node story. And that's just, it's too much. And that's why, if you look at all the attempts of storytelling, whether they're trees or, you know, some form of interactive fiction or Storytron or encounter-based systems, typically it's they stop somewhere on the order of 100 nodes. That is, almost every one of these systems has more than 10 nodes and less than 1,000. So, okay, 100, logarithmic medium. So there's that limitation comes from the gigantic growth. It's an exponential. It goes as a square. The growth of connection considerations with the size of the story. So if we ever wanted to build a really big story with like 1,000 nodes, we'd be talking about something like 1,000,000 connections, and that is impossible. There is simply no way that we can build systems like this. They're too complicated. Well, no way we can do it right now. There are ways to address this. What we need are fancy tools. And in fact, if you look at programming, the programming community has, over the last 60 years, developed increasingly powerful tools for creating software. And we need to think in those terms, in that way too. For example, here's a really neat tool I came up with for Storytron. I call it the Scriptalizer. Now, it's not anything you could use. Well, actually, you could. You could use it in the appropriate, in some kinds of interactive story worlds. But in general, I'm using it merely as an example of the idea of an advanced tool. Now, the first tool I want to describe, I forgot to put in here. Putting this lecture together was a lot of work. And that is something that is very easy to implement. And that is to use the idea from Storytron of acceptable and desirable. The acceptability expression is the Boolean selection factor, and the desirability expression is the numeric. So what you do is you go through and you do the Boolean calculation. So you got this, let's say you're doing storylet system with 1,000 storylets in it. Well, each one of them is going to have its little Boolean expression. So the first thing you do is you go through all of these and you select out the ones that meet the Boolean requirements, and that reduces it to, say, 50 storylets. Then you go through and calculate the desirability number for each of those 50 storylets, and the one with the highest value is the one you select. In a storylet system that uses just Boolean selection factors, you're going to get overwhelmed with way too many choices as that system gets bigger and bigger. So you've got to have something like the numeric desirability selection factor built in. That's easy to do. However, again, the interactive fiction community, I I'm not optimistic that they will embrace even that simple a concept. And so that's a major obstacle, I believe. But here's some other tools that could be used that I developed for Le Mort d'Arthur. This is the record. Let me just ask, my understanding is that storylet technologies are fundamentally choice-based. Is that correct? Or does anybody, Chris or Sasha, do you want to correct that?
I mean, probably it fits more into the choice-based paradigm. Like theoretically, you could build a situation based on like storylet style in a parser game, but just because there's a whole lot of moving parts and like a world simulation there, it's not so common. It's almost kind of more like Dwarf Fortress, where it's like simulating a whole bunch of things, and sometimes it's you're like in a desert and the place is desert flora and fauna, and sometimes you're in a tundra and the place is like tundra specific things, and so it's usually more of a choice-based sort of thing. Yeah.
all
Well,
the storylet games that I've seen so far are choice based rather than parser based. In principle, I think you could use a parser, but I haven't seen that.
Yeah. Yeah, like I'm thinking of like I don't know, like a game idea I had a long time ago, like sort of based on the I think it was like Star Trek like style of what was it? The mainframe games where like you would fly to a area and it would have like a certain number of enemies and things there, and like exactly what the situation would be could be like determined from a list, sort of like storylet style, and then it would place all of the different enemies and things based on whatever the scenario is. But I'm not sure that I've ever seen that implemented.
okay. Well, if you're using a choice-based system, then one big advantage is that, as with Le Mort d'Arthur, you can record every move made by every player. And so looking at this top line here, this is the player whom I have named Cree, and this is the date and time of that action. This is just screen size as a way of, I thought that'd be useful information. Turn number. So here's Cree going through the turns. And the name of the encounter, the choice made, he chose option 2, and then the values of various global variables. That tells you an enormous amount. And when you get all of this, and I have over a megabyte now of this kind of data, you can milk that for an enormous amount of useful information. For example, here's one thing that I turned out. This is the how long people took to make their moves. You guys, I've shown you guys this a few months ago, but you can see this tells you a lot about how hard people are thinking about the problems. Here's how many players completed how many turns. The vast majority of players dropped out quickly. Only a few made it to the end. This type of data is extremely useful, and there are dozens of useful ideas that you can get from this kind of record. Let's see, here's another one. Each of the players is analyzed, how many moves they made and how far they got in the story world. You can see only a few people made 345 is the minimum level. I'm sorry, 344 is the minimum level for finishing. So that's a very powerful tool, and I'm sure that there's a lot more information to be extracted. When you have a huge data set like this, you can learn an awful lot. The next idea, which I've also told you about, is the million monkeys idea, wherein, since it's choice-based and the choices are essentially equally or supposed to be equal or comparable, you can run a simulation of it where you just run through the whole game, except where you go out to get the user's input. Instead, you jump into another routine where a monkey makes the input by making a random choice. And then you pop back into the main thing, and it's basically runs through the whole game. And you do this, well, 1,000,000 times you could. I only bother doing it 100 times because I get the data I get from just 100 runs is good enough for my needs. However, you could probably take this concept and use it, run it a lot more times. It doesn't, I mean, 100 runs took about 15 seconds. So, you could do a lot more runs. But I could get all sorts of useful information about what random play generates, and then use that to establish the requirements for a player. That is, player's got to be better than a monkey. And how much better is the only question I had to ask. But I could also get lots of useful information on how various global variables developed. Even more valuable would be information on pathways that end up getting chosen. That is, there's a lot of dependency. If you choose path A early on, that may well bias you to getting into encounter 59 later on. And so if you think of the thing as a big tree, you can talk about the weights. Instead of just having simple Boolean arrows, you could have thin or fat arrows showing how often this particular path is traversed. You could then use the monkey data to feed back into your tree design, which then affects the results from the monkey data. You can set up software that'll do an automatic tuning loop. And you do that with a very simple thing. You take your desirable equation, and you would normally have the standard stuff, but then you add what I'll call a monkey fudge to it, which initially is 0, but as the system learns from the monkey behavior, it can alter the value of the monkey fudge to achieve better balance in the system. So that's another idea that could be used for improving the performance of these things and making it possible to build larger systems. I believe that is the, I'm going to stop sharing here. Sasha, you want to say something?
When you say achieve better balance in the system using the monkey fudge thing, what specifically do you mean? What would be more balanced?
Well, it's quite possible that you could have, if you're designing it as a tree, that you could have this big complicated tree, and you don't realize it, but early on there's a pathway that people tend to take. They seem to prefer this one, or the monkeys prefer to take it. And then that ends up with all this activity in this one small portion of the tree, and all these other encounters that you wrote are wasted because they're very seldom used. And if you're a theoretically perfect designer, you'll want to ensure that each one of your encounters that you spend so much time sweating over, each one gets used. So you could tune your system with something like that. But again, this is a very simple approach it could be vastly more sophisticated than that. I mean, we got a lot of room for improvement here.
I agree.
Pardon?
I agree. We do have a lot of room for improvement.
Yeah. So, but to summarize, I believe that the killer problem for all technologies for interactive storytelling is this 100-node obstacle we face. Yeah, it's not exactly 100. It depends on what you're building, but somewhere on the order of 10 to the 2 nodes, we run into a complexity problem that explodes on us. And we must build technologies that are capable of building much larger systems. Now, I came up with a real hack for that with Lemort d'Arthur. Hey, we won't branch at all. We can have, it's got 300 nodes in it. If you don't branch, it's easy. But, you know.
Yeah, I'm really interested in hearing more from Patrick because I think he has a good idea in using AI to help with that authoring, I guess. And I mean, like a whole lot of what was so tedious about working in Storytron was the need to define like all of the like relationships between characters, to set all of their starting variables for all of their like personality traits and everything, and also the like calculations as far as what like the desirability scripts for events and the results of the actions, and a AI assisted development for those sorts of things, like filling in just like the busy work kind of boilerplate stuff that doesn't need to be really carefully constructed. It just needs to like fill in the broad strokes, and then the human can come back and like fine tune details in certain cases. I think could be a really useful approach.
Yeah.
Yeah, thanks for the shout out. I mean, so in addition to writing boilerplate text, and in addition to taking a text input to generate JSON that for like a subset, you don't want to go one sentence at a time for like one encounter or something like that, or for like give me a scenario that's like a set of encounters. I could see that being possible. In order to get there, we need a lot of data. So we have to get busy anyway, and we have to do it without AI anyway for a little while. So my add-on here, with the 100 nodes and the 2000 connections, what you're doing by cutting that in half, Chris, is essentially adding a Boolean logic where it's like, here's part 1, part 2, or something like that, right? And like the template of all of the encounters are in one big soup, and it's kind of like Pulp Fiction or something. It's like one of those kind of existential, so, but then the randomness can create weird percolations. Like I could see that cropping up. But what I had prepped some notes on, and I wanted to like actually do playable experiments to kind of explore the math, is that if we're thinking in terms of the story world as a multi-dimensional space, not so the whole debate about should there be space, here's a Boolean, I'm in this solar system, well, just have one solar system, and suddenly that you're going to get easier time out of that, right? So ultimately physical space is a thing that you can do, but it's a distraction from phase space of all the variables, which is already really, really big. So you really want to use physical space as a sparing construct in the story world, and explore the mind space of the characters and their relationships, right? And then when you have an economy of moving around in those coordinates, that's by definition, that's metric space. So it's like everything's like a trade-off. And then I was looking at Hilbert space because I thought, oh yeah, this sounds like Hilbert space, and it seems like there's useful more complex stuff in that study. So But the simple stuff is you have like inner product equations. So the inner product of two orthogonal, completely orthogonal variables would be 0. And then there are variables that are co-catalytic, where you would have a different inner product, right? So if you're trying to tell a story about inner work that the character does or that the player does by replaying it and then role-playing the character doing that inner work, and that puts them in the position to be heroic where they would not otherwise be very likely to maneuver into that, they're doing something worse, right? That's something that you can do, and so on. Like, and for a romance, that also makes a lot of sense, right? So if one character is, so let's take it out of Hero's Journey, it's like been done to death. One character is neurotic, the other character is autistic, so they play off of their neuroatypicality, and it's the meet cute where they trigger each other in a funny way, and then you can make the variables reflect that scene, and the subtle role plays in a set of encounters that are bound by one spool, which is that we're in the scene, and then you jump through a bunch and you get somewhat different impressions in the meet cute, so it puts a spin on the resulting reorbit of the relationship, right? It could get into a friends to enemies type thing. That's very popular in romance, or rather enemies to lovers. Yeah, friends to enemies, enemies to lovers is like an arc, right? So you could have a few arcs. You could have a simple story world that's a romance, where there are multiple operational scenarios that come out of the spin of this early meet cute, and how you role play the subtle details of it. And so that could be about 10 turns, and then you have about 10 turns or 20 turns that are determined by that first situation. And then if you want to put a lot of work into it, you could do an act 3 and 4 and have a reversal, and but let's just say, as if this were an experiment one of you would do, it would be short, right? Because you would just kind of jump to an epilogue and say, okay, the variables are in a space where this is going to work out, extrapolate it, not do a whole big job, right? But I think it would still demonstrate good mechanics, and that's so I gave myself the exercise this month of thinking about lots of short story worlds, and I was talking with Sasha about this, and I came up with a bunch, and I ended up going back to this Medieval Saints role-playing game that I started working on last year, and so I got hyper fixated on researching that. And I didn't actually, because now I have to do a little historical stuff, right? But anywho, so that is my goal, and it's something I encourage you guys to do, is take like a game jam day if you can get it, and that's also been a challenge, and try to bang something out that's short, and then you'll want to go back and edit in more dough, and then they're getting a different pizza out of that dough, right? And because it's like, what could you do with a 20 or 30 turn story world? Like, a lot is the answer. So, and I think we can really build off of those foundations.
I'd like to,
without, I spent 2 years doing this giant story world, right? Which is also important. And I mean, I think, Chris, what you've done is good, because you're showing us also a way of doing content within the constraints of simpler math spaces. And yeah.
well, Patrick, here I am playing Cassandra about the failure to embrace mathematics, and I'm just talking about high school algebra, and here you are, tensors and Hilbert space, and I mean that's sort of a big.
But like high school algebra, you have an XY, right? That is a part of Hilbert space. You know what I mean? It's just a very prosaic part of Hilbert space, and you can do a lot in but you're gonna have, I mean, truly though. So thinking away from how big of a graph or graph logic, I think graph logic is limiting, but it's useful to constrain. So it's a formal constraint, not a material constraint. And the material constraints are these variables in the metric space in them. So how many variables do you have is actually a better question. And if we're already constraining ourselves to 20 turns and like 100 encounters, maybe more if we wanted to really polish this stone, you got to watch YouTube videos of the guy who polished his opals. It's kind of like being a story world author, I think. So anyway, in addition to that, I think if we have 2 main characters, so romance is good for this, And then how many variables at a minimum can that work with to be interesting? So how good is their relationship? Is that just one variable? Or is it like how happy are they about the relationship, and also how good is it in an inner dimension, right? That's something to contemplate. Let's say we have a simple one, and then they're going to each have, I don't know, some presets, really, some attributes that weigh their ability to maneuver towards optimizing that number. And that would be, I think, the simplest thing, and it would keep you busy. And yeah, it wouldn't keep you so busy that it'll take you months to do it though. So that's the thing. And then I think we can build from that. Once you get a cast of characters with their own internal state variables, and you have a simple model that's like 3 or 4, you are talking about you are talking about a Hilbert space with several dimensions to it.
Something you said just triggered an idea for me, and that is to do a straightforward multi-dimensional analysis of the values of the global variables in Le Morte d'Arthur. Now, there are only 5 of those, and so it'd only be 5 dimensions, so child's play. But there might be some interesting results coming out of that. But we're out of time here. But does anybody have any final comments or questions they'd like to make?
I think one of the main difficulties in making these sorts of story worlds is that you need a certain length, you need a certain number of encounters in order to change the relationships meaningfully. Because the idea is that you're, over the course of the game, you're building relationships with the characters, you're building affection, or you're building trust, or you're building your ability to intimidate them, or different things. And because it's this additive thing rather than a Boolean thing, like Chris is talking about, you have to have enough encounters or storylets to split the different paths to change the relationships in a meaningful degree. And the more variables you have, the more subtle and compelling your narrative can be, but the more encounters you need. And that leads to the problem that Chris Crawford's talking about, where you have so many connections and it places a large workload on the author. But I remember in last year's Game Maker's Toolkit Game Jam, the game that I made with Chris Conley and George Dawson, I wrote, like that was a 48-hour thing, and I wrote basically two conversations with a couple of different characters, and I wrote quite a few different encounters for those two conversations. But even within those two conversations, it was really hard to get enough interaction to change even just one variable with each of those characters. So it's the sort of thing where I got the impression I would need multiple conversations with each character to really build the relationships with the player and those characters to a meaningful degree, and have enough character development to make the story really work. So
yeah, I mean, I think that it's because the early scenes need to just establish the relationships as they begin, and you need to have that foundation before you can even start to modify things based on choices, because otherwise the player doesn't really have an idea of what their choices mean if they don't have any buy-in or understanding of the other character.
exactly. Yeah, at the beginning, when you have different ways the characters can react, they're going to react the same way because the game's going to start with the relationships in a particular place. It's only after you have several interactions, several choices that the player can make to change those relationships. It's only at that point where you can kind of branch and have the characters choose different responses based on those variables and have them actually have different responses that the characters might actually choose. So it's, I'm not sure exactly what the solution is yet, other than, you know, the direction I'm going to try and go in is just having a lot of different conversations with the characters, have enough content to develop those relationships, and I guess keep the number of global variables relatively small. You know, I think Chris Crawford's classical model is to have 3 variables, there are 3 different types of variables: affection, trust, and fear. And I think that can work pretty well. But it's a hard problem. We need more people to try making games like this to really experiment and see what works.
Yeah, we need a lot more experience. So.
Yeah.
Okay, well, thank you, everyone, and I'll put the recording up on YouTube a little later today.
Can I
And
give a shameless plug?
sure,
So
yeah.
I'll be giving a talk at Narrowscope this June. So I'll be talking about my my tool Sweepweave for developing interactive story worlds. I'll talk a bit about how it works. I'll be I think of Sweepweave as a type of storylet system, and it does use both acceptability and desirability scripts for selecting the encounters, and it uses the global variables for the characters and so forth. So I'll be going over kind of the basics of how my system works, and uh, building on a lot of the ideas that we've talked about today, I think. So I hope that everyone will at least tune in online. Some folks might be able to make it there in person, but all the talks at Narrowscope will be recorded and uploaded to YouTube. So
By the way, you and I need to get together to talk about that. So just
yes.
time when it's convenient for you.
Yeah, I'll send you an email about that with a particular day that should work.
Okay, very good.
Thank you.
Okay, well, I will see you guys next month.
Thank you so much. Take care.
Okay.
Bye-bye.